There we go. I'm recording now. So yeah, I just missed just a little bit of content there, but nothing. It was just me talking, kind of a bit of nonsense. But yeah, so we're going to be doing kind of a hybrid presentation and workshop. It might work, it might not work, but at least there'll be some content in it that you might find useful. Um, So through the course of this presentation, I'll kind of be tabbing in and out, as I've said previously. But sometimes I'll have something like this. And these are kind of pre-programmed kind of responses you might expect from your command line interface. So here I've just done the cat command, and this is kind of what the cat command would look like if you had some kind of file called somemorinformation.txt. So, yeah. So, just a tiny brief thing before we start. Git is version control software. I forgot to include this in a slide, so I have to make it explicit here. It's source code control, so you don't deploy compiled code to Git. So if you have a Java project, you would never upload a .class file to using Git. You would only ever upload your source, say .java files to it. So anyway, yeah, we'll get started. So we do need to get started somewhere, and that somewhere is initializing a repo. So in this instance, we're basically telling Git that we have a directory, or we'd like to create a directory in which we will store files, and we would like Git to track for us. So the way we do this is with the git init command. If you're in a directory and you want to create a new directory for your project, you would do git init and then the name of the repo you'd like. So here we've done git init github_example, which has initialized an empty Git repository. So we're currently in home GCLI Git, which is my big folder full of directories with Git projects inside of them. So it's initialized one here. If you already have a folder and it's got files in and you want to start tracking them, just cd into that directory and type git init and it will do the same thing. But either way, following on from that, if you cd into change directory into your new Git version controlled directory, it'll probably be empty. So we want to add some files to our directory. So what we're going to do is we're going to add a README file. This is kind of a standard kind of Git hub, GitLab kind of README file, capital readme.md. It's a markdown file. And when we do this, so we just use the touch command just to create an empty file called readme.md. We do git status, so we query git for the status of all the files in the folder. It says that there are no commits yet. We'll get onto our git commit in a second, what that is. But we have one untracked file, readme.md. So it's basically saying that it's not tracking it at the moment. So to remedy that, we will do git add and the name of our file, readme.md, and then if we do git status there, we can see we still have no commits. We're on the master branch. We'll talk about branches a bit later on, but it knows that there is this new file and it's ready to be committed. And we'll talk about commits in a second. Before we can get to do one of these mystery things, we have to set up Git first. So I should mention, if you have Windows, this will be in Git Bash. If you're using Unix, BSD operating system, base operating system, say for instance Linux, Mac OS, that kind of thing, you'll need to, in your terminal, do this. And if you're in Windows, obviously in Git Bash, you'll do git config --global user dot and then substitute in one of these, and then your name and your email address. This basically just makes it so that your commits, and we'll get on to what commit is, your commits are kind of associated with your name and email address. You won't be able to commit anything without doing this, and if you try to anyway, it will just tell you to do this anyway. And I've also written here that you can also sign your commits. That isn't necessary now, but you might want to look at doing that a bit later on, just so that people know that it was actually you who committed something and not someone else who has signed up to Git or Git, with your name and email address. But at this stage, say for CSCM 94, you won't need to do this, but at some point you should. Anyway, so a commit. What is a commit? A commit is kind of a snapshot. It's a frozen point in time where all the files in your directory were in a certain state. So we've created a commit here. So we've done git commit -m, and we've called it initial commit. You can just type git commit, and then it will launch your system's default text editor. I think if you're on, say, a Unix or BSD system, it'll probably be VI, maybe Vim, probably VI though, or Nano, GNU Nano. But I'm not sure what will happen if you open this in Windows Terminal. Probably the same, probably GNU Nano. So we do, but here, if we use the -m flag, we can specify our command to create, our message that goes along with our git inline, which just saves just a bit of time. And because commit messages are quite small anyway, it probably makes a lot of sense to do most of them from the command line. So in our commit message underneath, it tells us we're on the master branch, which is kind of the default branch, and we'll talk about branches later. This is the root commit, which I think means it's the first ever commit. And we have our git commit hash, I think they're called. This is just the small concatenated version of this. This goes on for about that many characters normally. This is just a long hexadecimal number that is unique to each commit. And you usually, if you want to revert something, you'll put this small one in. You'll say, oh no, I've messed something up. You can do git revert or git rebase. There's a couple of commands you can do. I'll find for you. It's difficult to say exactly which one you'll need, but people have made excellent resources online for, I've messed up, how do I undo this? And there are many different ways you can mess up, but people explain it really well. I'm not going to do that, because that would take too much time. So that initial commit, there's our thing, and this basically just says what has happened since the last commit. So these are the instructions really for these are the human readable instructions from Git. So this tells Git how to recreate this commit at one point. So create mode 10644, those are the file permissions, if I'm not mistaken on those. So create mode, the file permissions, and then the name of our file. So that makes sense because we've got an empty file and we've just created one, and that's what's in our initial commit. Anyway, okay, so here's a live demo. If you'll just give me about just a couple of seconds, maybe about a minute. I was testing setting this up last night, so I have already created a GitHub_example repository on GitHub, and I have forgot to delete it, which I apologize about there. So shouldn't be too long. And I'm going to do git rm-rf. I can never type when I know people are watching, or there is the opportunity for people to watch. let me get rid of that, and dot slash, I've just automated creating a lot of this stuff. So we'll just leave that there. And we'll go over to the website. So here's what GitHub looks like. We'll just ignore that a second. You'll want to create a new repository. I'm going to show you this in GitHub. There is a way to do it in GitLab. It's the same thing, but I'm just going to focus on GitHub because I don't want to do two things for each one of them. They're basically the same website. I would say that GitLab is less ethically dodgy than GitHub. GitHub donates lots of technology and resources to ICE, which are a US governmental department who do horrible things to migrants. So probably don't shower them with your attention. But in this instance, people who get started seem to like GitHub, so I'm going to use GitHub here. So you click on New Repository. We're going to give it a name. I'm going to call it GitHub_example. We're not going to give it a description for now. We're going to keep it public, and we're going to skip all of this stuff here. Click Create Repository. And then what you basically have to do is just do these commands at the bottom. I've automated a lot of that, so what I'm going to do is I'm just going to sign into GitHub in my other terminal window, which is off screen. I've done that, and let me just refresh the page, and we have our GitHub example page here. If you just ignore this readme.md, this is from a later part of the session, but here it is. So we have our readme.md here, and we should see our initial commit. This is our initial commit we created, that, and the commit IDs don't match, unfortunately, because every time you do one of these, the commit IDs will be different. So it was something like EB something on the last one. Now it starts with 1B. So you can see that they change each time you do this. So let me go back to the slides. And then there's another live demo I created. It is what it is. Anyway, we're not going to do that. We are going to do this, cloning. Well, we're not going to do this at the moment. So you created your Git repository. What about your teammates? So your teammates will also need to access your remote repository on GitHub. And the way they go and do this is they'll go and do git clone, and then there's a repo URL here, and it will clone everything and set up the repository as you'd expect. The way you find that is if you go back into your repository, you can either just take this from the URL bar at the top and add .git to the end, or a little bit easier, you click code and you click this, the little clipboard icon here, and that will copy in this address. And that's as simple as it is. I should mention that in the previous section it tells you to basically change the master. When you set this up, it tells you to set master to main. I haven't done that, and it just makes it a little bit easier. But if you follow it exactly, when I say master, you should substitute that with main if you follow the instructions from GitHub specifically. It's all to do with language. It's kind of outdated language to use master as a word, but here I'm just using it because it means that I have to change the mental model in my head, and worms live in my brain, so that's quite difficult for me to do. But anyway, if we go back to our slides then, so this will be how your teammates will access your repository. You may need to go through and change some of the settings in your Git repository, in your GitHub repository, sorry, to allow people to contribute. But you won't need, if you set this as public, you won't need to do anything like that. I would argue you should probably set it up as a private repository, and then when on clone you'll be asked to log in. That would probably work. I am going to be doing things in my CSCM94 group as a organization, I think it's called. You can do that. I might do that. I might carry on and do that, but I might just go and set up a private repo. And then when it's time to submit, I'll just change it to a public repo. Anyway, it doesn't really matter, but you can go and look into that if you need to. Okay, so I've said, so far we've committed things to a master repo, which is the kind of main branch. But you should probably not do this. It's okay when you set up a Git repo to commit to master, but if you think about it, a master is kind of like sometimes a master branch is kind of the production branch. So if you push a breaking change to a master branch, you won't have a fun time. Is basically the way I might describe it. Yeah, so don't push to master unless you're pushing something very small, non-breaking, and it's at the very start of your project. You should probably always branch off. Yeah, that's very important. So always branch before you make a change. It's basically, if you think about, this is your main branch, it comes off. You can kind of branch off, and then later on you can branch back in. So you can do all of your commits in here, check it works, and then branch back up into your main. Sorry about the hand gestures. I don't have the budget for snappy, nice visuals, so I've got to go for that. So yeah, almost never commit to master. So the way we go about branching, we make a local branch, if you want to, is we do git checkout -b make. So we're going to make a branch called make readme. We already have made a readme, but this is adding the changes I showed you in that Git repository. Just pretend you haven't seen that online hosted repository. So here we're going to be doing that, basically. So we're going to check out and create a branch called make readme. What you would probably normally do is git branch name, and that'll create a new branch, and then you do git checkout and then your branch name. If you do it like this, it saves you, I think I calculated it to be 8 keystrokes. So efficiency matters, no? So git checkout -b and then the name of your branch, and you'll create and switch to a new branch, which you've specified here. So here we're going to make some changes to our readme file. So on the new branch, all of your files from the previous commit that you branched from will be there. So currently there'll be a blank readme document there. So here I'm just adding some lines to our readme file. So I've added a heading, which is GitHub example readme, and then we've got some lipsum. I only know the first couple of words of lorem ipsum, which is lorem ipsum color dollar sit amet. I get to that point and I'm just like, I don't know the rest of this. But I've opened enough blank Word documents and publisher documents from the mid-noughties that has like been permanently etched into my brain and it will never leave. So yeah, whenever I think of, oh, I need to write some text, I go lorem ipsum color dollar sit amet ... So we're using the cat command and we're piping in cat. This is a way you can pop text into a file, and multi-line as well. So we're looking for this EOT flag in here, doc. This might not work in your it probably will work, but it might not work in your terminal environment. Either way, just open text editor, pop some stuff in. Then we're going to do git add -a and git status. This is the short circuit and, I think it's called. This git status will only succeed if this hasn't errored. So if nothing's been pushed to standard error, I think the way it works from this, it will do git status, and it has. So it's on git add -8, that produces no output. Git status, on branch make readme, changes to be committed, and we have modified readme.md. This is different from last time. Last time it said create file readme.md, but here we've got modified readme.md. So git commit-m added content to readme.md. So we have added content here, and we have one file changed, 2 insertions. Great, because we've added 2 lines. Anyway, so we've looked at this, we've determined this doesn't break things, but we'd like to merge this with master now. So the way we do that is we merge them together. So we've branched and we're going to merge. This is a local branch, so this might be something you change yourself. It's not something you want. It's not a change you want to share. So you just create a simple local branch, and you make a change. So I've called this cha-cha slide because you slide to left, kind of like merging. Jokes never funny when you explain them, I guess. So git checkout main, we're going to do. So we saw the checkout command earlier. The checkout command just switches your git onto another branch. If you do git checkout main, it's actually master on mine. Sorry, that's a mistake in my slides. If you do git checkout master or main, and you look at you cat your readme.md file, nothing will be in there. But if you check out back into your other branch, it will magically reappear because we've made a commit on that branch. That's the wonder of Git. You can have these branches, you can have different changes on different branches, and you can switch between them. If you've made a big mistake and you want to see what it looked like at the last commit, you can revert, you can look at the last commit, you can look at a branch before you made the commit, you can make the changes, you can do a lot of different things. You can use git log, loads of stuff. So we've done git checkout main here. Your branch is up to date with origin main. Origin main is our remote branch, and that makes sense because we haven't pushed any changes to the main or master branch on our GitHub, and no one else has. I think it does a git fetch when it does this. We'll get on to git fetch, but it checks basically, or it has memory of the last time it did git fetch. And what we can do is git merge make readme. So make readme was our branch we created where we added the changes to the readme file. We can do merge. It will. This was our first commit, and this was our last commit. So it's updating those. It does a fast forward, which is basically git speak for I'm going to summarize what happened here because we had to do a couple of different things. So it does fast forward, and on readme.md we had 2 insertions. So that's looking at the change on master and then the new commit that has been merged in. There are 2 changes. Makes sense because we changed those on the branch. So that's merging a local branch. Now, what happens if you want to branch out and you want everyone to be able to see that branch? We have to get into the world of remote branches and pull requests. So, yet again, another live demo. Twice in one lifetime. So here's our Git repo. Sorry, I've got a bit of an itchy nose. So this is our Git repo, and no joke, whenever I use GitLab, I can really easily find the new branch button. If you can spot the new branch or an option to add a new branch from looking at this, I'll be very impressed. Did you guess that the new branch is here and then you have to type in the name of the branch, and then create branch new. Would you have guessed that just from looking at this page? I know I didn't when I tried to do this the other day. On GitLab it's much easier. I don't know, the UI is a bit jank sometimes on GitHub. This is one example of it being a bit jank. But we're going to create a new branch, a new remote branch called new. Click on that. Normally you'd want to be a bit more descriptive with the names of your branches, but here I'm just going with new because we all know what it is. But you might say something like correcting and then a hash of the commit ID that maybe balked main or something like that. But we have a new branch basically. I'm just going to check. Okay, so we have a new branch, and if we run git fetch on this new branch, we will be able to see basically what has been done here. Anyway, so let's have a look at that. So here's git. I'm going to cd into our GitHub example. I'm going to do git fetch. Once again, as you can see, we have got a new branch here that is picked up from origin new. So origin new is set up to track this origin new branch, which is the remote branch on GitHub. And what have I done here then? So yeah, we can have a look at README. So this was the change we committed. GitHub example README. Lorem ipsum color dollar sit amet. That was the last change we made. Now, what I've done here is I have changed this, and I will change that now. So I'm going to pop over to the text editor. Space F. I don't have the text editor open. That would be a good start, wouldn't it? It's not space F, it's space dot git GitHub example readme.md. There it is. I'm going to make a change to this. I'm going to say this is I am making a change to readme.md on the new remote branch. Oh, no. Sorry, my bad. Yeah, this is not what I wanted to do. Let me just not do that. Let me exit that. Sorry, that was my bad there. I think I switched out to... Yeah, I haven't written it here, which is why I forgot to do it. Yeah, so what you need to do here is git checkout new, and then I'm going to open readme. Which has magically not appeared. You can see why I am not a streamer, because things like this happen way too often. There we go. So here we go. If we just pretend that didn't happen, you can all be very kind to me. Here I am adding new information to our readme file on the new branch, a local branch which is tracking the remote branch, also called new. So yeah, we're making changes here on the we're making changes on new, which is our local branch, which is tracking our remote branch. and we should be able to see that in just a moment. I can see here that we are actually modifying. This is part of Emacs. It's telling me that we are actually operating on the new branch, which is a branch called new, not a new branch, a new in quotation marks branch. Anyway, that's enough useless talk. So I'm just going to copy paste this in right there. Oh, just need to close Emacs. So there we go, git add git commit -m commit on the new branch. We are in new. This is part of my ZSH shell setup, so I can see which branch I'm working on. Probably won't get that on yours unless you set it up correctly. And then what we're going to do is we're going to git push this. It's the first time you've probably seen me do a git push on camera. And then I'm going to type my password out without saying any of the characters in it, because that would be bad. Nobody please access my GitHub page. And here we go. And you can see on this page, I haven't even refreshed it, but it says new had recent pushes less than a minute ago. So we are on master here. If we look at new, which is our remote one, these are the changes we just made in just now. So if you look at this, GitHub will, for Markdown files, add its own syntax highlighting, but you can look at the raw one here in the web browser if you click raw. It will do syntax highlighting. Well, this is just, it's styled this with CSS, this Markdown. There's some kind of something in the background, I guess, some kind of pandoc system in place. Could be wrong though, could be something custom. But anyway, when you upload source code, it will normally be formatted with nice color-coded formatting, the kind you get in a lint on a IDE or something like that, or even in Emacs. So yeah, right, back to the presentation. Got distracted a little bit there. So we're going to now merge from a remote point of view, and to do that we're going to do a pull request. So yes, third live demo in this presentation. This could end badly. No, it won't. So back to our web page. So here is our repository. I've realised, like, talking for a long time, you really do have to take a drink every now and then. So yeah, so if we want to merge these together, we can do that in GitHub using a pull request. You can either, well, sometimes you'll have a big button at the top saying compare and pull request, or you can just click on pull requests. You can then create a new pull request, and then you'll want to compare two branches together. So there we go, we are comparing changes on master and new. If you click the create pull request on the main page, it does all of these steps for you. But here is our previous version on master, and here is our new version on new. So these are our two examples. You can create a pull request. So the difference is between merge and pull request is locally you are the only person really who is dealing with those branches locally. So it would be kind of silly to ask, would you like to create a request for yourself to merge these things together? That would be quite silly. If you're working in a team on GitHub, you might have someone creating a pull request, and then someone needs to sit through and say, hey, this would be fine to merge this in, or no, this needs work, go back and make these changes, because if we merge these in, we'll break something, right? So we're basically comparing before. In this case, it will be me who creates the pull request and me who approves the merge request, the pull request, sorry, which is a little bit silly, but on a proper setup with your actual team, it will be something different. So we're going to click Create Pull Request. You can add some comments in here. So here is an example of a comment to be added with a pull request. I can't believe I typed all of that without making a single typo. That is incredible. I never have that kind of luck normally. So create pull request. Then GitHub will do a little bit of automagic checking, and it will say this branch has no conflicts with base branch, which means that we can merge these things in and it probably won't break anything, or it won't create a situation in which we have weird kind of duplicates of lines or that kind of thing sorry about that, kind of thing in syntax in your file. It can merge it basically. So we will merge. So I, as manager of my own project, will merge this pull request. You can go in and you can. So that was the commit that's being merged in. There have been no checks. I think this is where you might set up some kind of. I've never done this, but you might do it like that. I have checked that and I deemed this to be a thing that's suitable for merging, so I'm going to merge the pull request. Indeed, I'm going to do that. Click merge. Okay, so that is merged into the main branch now. So master, we still have our branches, but we can see we're on master and our merge has taken place. This is the readme on master, and the last commit was a pull request. Right there. What we can actually do though, you can do this, you don't have to do this, is if we go back into our pull request, we can now tidy up this branch. We can, if you want to, delete the branch, you don't have to. I am going to delete that branch. You can obviously restore it later, depends what you want to do, but go back into our code and the new branch has disappeared because I have deleted it. So that's pull requests. I have 3 slides left. I can't remember what's on the rest of the slides, but we'll find out. And also we're going to be starting, this is very much a live demo. There will be no supporting slides with this. I will be attempting to do an ant build, and it could go well. I've tested it. I have tested it, but we'll see how that goes. Anyway, back to our slides. So, as I've said, source code only. Yeah, these slides do detail what I want to explain. See, I have prepared. So, source code only. Git is used to track changes to source code, not compiled code. We are going to want to create a file which tells Git to ignore all of our source code. Otherwise, when you do git add -a or git add *, it is going to pull in everything, even stuff we don't want to commit. We can tell Git we don't want this in advance, and the way we do that is through something called a .gitignore file. So here we're adding a sample gitignore, and we're just excluding class from that gitignore. So that's really simple to do. I'm going to do echo.gitignore. Oh, no, we're not. I'm going to switch to the master branch, which, as I've said before, you shouldn't do. Do as I say, not do as I do. Git pull. Okay, so that was just the changes we just made on. I just circling my mouse on the browser. You can't see, but the changes we just made have now been pulled to our local repo. So what I'm going to do is I'm going to echo cat.getIgnore, sorry, not .getIgnore, asterisk.class to .getIgnore. So when we do cat.getIgnore, we have asterisk.class. So we're going to be doing a Java project, so it makes sense that we don't push any class files. So yeah, good. Then I'm going to basically just steal this line because it means I don't have to type so much. It's what I wanted to do anyway. And what I'm going to do now is, before we start doing any ant, I'm just going to do some very, very, very basic Java. We're making a hello world file, basically. So I'm just going to set this up. I'm going to go into my text editor. Device not connected or available. Of course it isn't. When is it ever? So we've set up our getIgnore. Now what I'm going to do is I am going to create a GitHub example, hello.java, insert, right, public class hello, public static void main, string array args, you know the score by now. Public static void main system.print system.out, sorry, .print. Oh, it's hard to do this while people are watching. Hello, comma, world. End, pop a semicolon, that's perfect. Okay, so now we have our, so if I do git status, it's going to tell us we are not tracking hello.java. I'm going to compile this, yep, and let's just sanity check this. It does work. Now what happens if I do git status? You see, we do have a .class file here, but because we've added and committed our .getIgnore file, and we've basically said, I want you to ignore every class file, when we use any git things, it will just pretend it doesn't see it. It sees it and it goes, I'm pretending you're not there. I'm not looking at that. So we're going to, I guess, just steal a little bit more. No, I didn't write it in. So I'm just going to go and grab the previous one, git add, and I'm going to change this to git add -a, and then git commit added basic Java application. So git status. So we can see now our branch is ahead of origin master by 2 commits. That's fine, because we're going to do another git push. I did type my password incorrectly. Well done. So back in the web browser, let's have a look at that. There it is. We have our .getIgnore, which we added 3 minutes ago, and hello.java, which was committed 27 seconds ago. But crucially, we don't have a hello.class, which is what we want to avoid. So here's our hello Java. As I said before, we get this nice, you get a, well, it depends on your definition of nice, but we get this formatted Java code there, which is good. Always my web browser decides to play up at some point. Also, if I click on one of these commits, when I was talking about SSH and signing commits, this is the kind of thing I'm talking about. So this is my this is the fingerprint of my GPG key, and that's, yeah, it uses GPG, or is it PGP or GPG? GPG is like the implementation of PGP. Someone correct me if I'm wrong. Anyway, but yeah, I am actually, while I'm here, I am going to check at this point if I have any questions. Okay, I do have 3 questions. Sorry, this is I have to open the stream manager separately. Banana EMP asks, is the small number the first part of the longer hexadecimal number? It is. It is. It's just the very first part. And also reacted with brilliant and nope, whoa. I don't know what those are in reference to, but I'm glad you're having fun. We have 3 viewers at the moment. Hello, 3 viewers. Once again, I can't see who is viewing my stream, but I hope you're having a lovely day so far. This probably go on for another 30 minutes, so hopefully you'll have time for some lunch after I'm finished. You're very welcome, Banana EMP. Right, so back to the presentation. So source code only, as I say. Next slide. .git ignore in action. I have just done this. See, I've jumped the gun a little bit there, and that was fine. Okay, so this is the live segment. I do have my notes in front of me for getting this to work. I don't have the slides for it, unfortunately. So this is going to be very seat of the pants kind of thing. Do we have any more information in here? So, as you can see, I got to the point where this didn't work. I've figured out why it didn't work, but I haven't updated the slides with the reason why. This is also not the full YAML code. Not code. Okay, Luminaga says, I have to go now, but I'll watch the rest on YouTube later. Cheers. See you later. Hope you found this fun. Yeah, I will upload this to YouTube probably, maybe this evening. It might be next evening on Sunday. We'll see how it goes. So this should hopefully not take very long for those who are remaining to watch. So what I'm going to do is to get this set up. So yes, I need to open this in Chrome. Is it going to? It's not going to do it. It never does it. So yeah, building. So we're going to use ANT in CSCM 94, which is the Software Engineering Principles lecture series. We're building the Mancala project. So we need to use ANT as a build manager. Thomas specified that is one to use. We're not using Gradle or Maven. I've never used those anyway. So yeah. So what we're going to do, I'm going to switch over to web browser. There is a really good set of documentation here by GitHub, which just tells you basically how to set up, if you're using ANT, how to set that up with GitHub Actions, so that when you commit and push to a branch, say master, it will do some checks and it will build using ANT, and you can look through those logs basically to see what happened, what went wrong. I'm only going to focus on compiler errors because I've tried getting JUnit to work and it didn't quite work, and I slightly ran out of time. This will be something you probably need to look into though, because you will need to use JUnit. So to get this started, we are going to need a ant build XML file, and there is a really good one on Apache Ant, the website. It's just down here. You can copy this one in, like this. And if we go back over into our text editor, Control-Alt-3, I am going to go here, and then we are going to make a file called build.xml. So what we're going to do is we are going to paste that in, make sure we're in insert mode, and I'm going to name this hello. Default dist based directory. Okay, this is like XML. I'm not going through this, but it is very nicely commented for you. So you should probably use and expand on this one. I'm just going to check. Do I have any more questions? No, good. Okay. So there's our build file. That's fine. I'm going to switch back to our terminal. What we need to do is, because we are going to, okay, so this ant file is going to pull files from a folder called src, which is our source code. So this is our, yep, so that's our directory. I'm just going to clear the screen because there's a lot of stuff on screen. So what we're going to do is we're going to make a new directory called source. I'm going to move hello.java into source. Let's just check that. So there's hello.java in source. I am going to remove hello.class, and I think we do have everything there now ready to test. So if I do ant, it's going to build. The build was successful. Brilliant. There's a couple of errors, but we just ignore those. Anyway, so there's ant. What we want to do now is it has created two new folders called dist and build. Build is where our compiled classes go. So if we go into, if we change into build and we run, we get hello world, as we expect. But we do need to get rid of, well, we don't need to get rid of, but we need to make sure we include anything that's in dist or build in our git ignore. So once again, we need to go back to Emacs. All the editors are available. I just like Emacs. So we are going to go into our .git ignore file, and we need to include within this file, I've already forgot what they're called, dist, and you put a slash after it like this to tell it that anything in dist should be ignored, and also build. So with any luck now, unless I've done something really stupid, when I do git add .git ignore, and I git commit -m with changed git ignore to ignore and files and created files. If I do git status now, yeah, so it says that we've deleted hello.java. We haven't really. It's just been moved into source. I was just checking then just to see if I had actually deleted it. I haven't. And we have build.xml. So if we do git add -a status, it'll probably pick up on, yeah, so we've moved or renamed hello.java to source hello.java, and we have a build.xml file. I'm going to commit these with the message, these and let's not think of pros. These are initial and project commit. Good. And I'm going to push all these to my remote repo. I need to say nothing when I'm typing my password in because it's in the forefront of my brain, and I know for definite I will accidentally say it out loud at some point, so I have to focus. So back to GitHub. We've added those. There's source. There's our hello.java. It's there. There's our build.xml file, which we've kindly pinched from Apache Ant. So at this point, we now need to set up the CI/CD. So this is in Actions. We're not going to use... I've lost the ability to scroll in this web browser. Okay, there we go. This is what happens when you use a computer from 2014, which has not been upgraded very well. Sorry. Here is... yes. So what we're going to do is we are going to set up a YAML configuration. So we are actually just going to... Is it this? It's this. So this is the one we'll be using. So what this does is this is a basically just tells GitHub how to set up some Docker containers to do things. So it's saying on push branches default branch we'll be changing this because that doesn't work, or a pull request on that branch. We do job, which is called build, and that's, I think, build in the Ant sense. Yeah, so there's a job, and this job is called build. Sorry, this build job is listed below. So it runs on Ubuntu latest, so it will pull the Docker image for Ubuntu latest, and then the steps it takes while doing this is it will use actions/checkout. So you can go to the Actions, I forgot it's called Actions Store or something, and these are basically just a big kind of store of very similar YAML files, and it will basically go through that one, do all of its steps, come out, and then it will do the next one, which is set up Java. So in this Docker image, it will set up the JDK, and with Java version 1.8. See, I read 1.8 as like 1.8. That's like from the 90s. Maybe someone will correct me, but apparently that's quite new. This is from 2020, so I can't imagine it being really old. But maybe look into that. There is a big list of other versions you can use, and in fact, in here it does tell you somewhere. Yeah, here you can change the JVM version and architecture if you want to. But we won't be doing that. But I will just steal this. Naughty, naughty. It's fine. I think this is it's the MIT license. So if I really cared, I would just make sure that the license of my project matches the license of this. It was acceptable, but don't tell anybody. I'm not going to do that because I am just going to delete this repository after I've done with it. Anyway, so I'm just going to take that. I wonder if anyone's going to tell me off for doing that. Good. Nobody's noticed my crimes. So we're going to change back into... Are we? Yes, we are. At the moment, we're still in our .gitignore file. Let me open Emacs. We need to... Actually, no, we need to go back into our terminal first. because I am simple-brained and I don't know how to create a new directory in Emacs. Sorry. So let's have a look at, let's do tree again. We need to create a .github folder in our directory, and in that .github folder we need to create a subdirectory called workflows. And then I'm going to go back into Emacs and I am going to make sure I'm in the right mode, and then go into .github. Oh, why do I do this? And I am going to create a new file called ant.yaml, just to keep in with that one that was on GitHub. And then I'm going to paste this in. Now the change I'm going to make is what I have down here was this default branch directory thing here doesn't work. Our branch, our main branch, master branch, is called master, and our pull request one will also be master. That, I think, should be everything you need to do with that one, just to get this working in this sense. So, without further ado, back to the command line. I'm going to clear this. So what we need to do is git status. We have added a .github file -a. So look at that. So we've created our ant.yaml. Now I'm going to create a commit. YAML. Oh, sorry, my bad. Forgot the -m flag there. And then I'm going to push this. I have to be quick now. Type my password in. Once again, being very careful not to. Okay, so I'm going to click enter here. Return. No, I'm not. I wasn't on the right page. Okay, now I'm going to go back into the browser, and if I refresh the page with any luck, oh please work. Aha, there we go. So it has automatically detected that we have a YAML definition file set up. It's going through with ant right now. It's completed, and we have succeeded in building. So there's a little tick here that says, yes, this build was successful. So if you want to, so if you go back into your thing here, so this is the most recent commit, there's a little tick here. The tick means it has done the continuous integration check you've specified. And if you go into your commit, yeah, that is what we added, obviously. But if we go into actions, we click on this. This is the build step in that YAML file, and it went through. So it's pulled in the just the underlying things that are referenced in that YAML file, so it's done those first. The ones, so that would be actions checkout v2. This is something we didn't add. This is just things it referenced to do. Then we had the setup JDK 1.8 step. It did that. And then there was a build with ant step. So we can see this is basically the same as our Java C output from ant build locally, and the build was successful. It created a it created these folders. It created them in the runners directory here, because it just leverages a container. In that container, it sets up a user called runner, and then it does all these in the Docker container, and then it should sometimes, it does sometimes, if you specify it to do so, it will spit these out and you can have them as a release. I'm not doing that, but you can do that. So there we go, it built a jar. It just gets rid of it though, because you've not told it to do anything with it. It does this post cleanup stuff here and then completes. It was that simple. So what I'm going to do now is I'm going to show you, this is the last thing I'm going to do today, I am going to show you what happens when you deliberately introduce, well, I'm going to deliberately introduce an error, but you might unconsciously do this. So if we go back into, I've not made this easy for myself really, I have to say, my setup. If I open, if we go back up again, back into source, back into hello Java, what if we do something very easy and we go to the end of this line and we just get rid of our semicolon. Okay, easy. If we go back into our terminal and we say, hey, Ant, can you check this for me? Can you build this? Build failed. Why? Because Java C says there should be a semicolon right here, which we know. But let's say some of your group aren't as proactive at checking this as you'd like them to be. So what happens if you push to GitHub and there's an error in building? Okay. So what you'll do, let's say git add -a and git commit -m deliberately added error to source code does not compile. Obviously, if you committed something with that message, I think the people in your team would be terrified. I don't know. Deliberately introducing bugs into source code and pushing to master, that's not a good look, I have to say. But we'll just do it and git push. If I can type my own username, that would be very good. Now if we go into our, into there, refresh this, we have started doing our thing here. It's starting the workflow, setting up the job, and it's about to go on to build with Ant. It's looking at it, uh-oh, error, process completed with exit code 1. Why did it fail? So, yeah, we've got a big X here now, and any moment now, I will have an email from GitHub saying, hey, someone has committed something to master on this repository and it's failed. You can also set this up in Discord as well. You can set up a, yeah, it's just come through there. Annoyingly, I haven't set up my emails to display, say for example, in screen share, but I will just show you. So you get an email like this. This is, oh god, but you probably won't be able to read it, but it just says, Java CI, all jobs have failed, because that one job, the build with Ant, has failed. So there you go. If you push bad code to GitHub, your teammates will know if they are set up in the Git repository in that way. So yeah, that's it though. That's all I really wanted to say. I was going to introduce a runtime error with JUnit, but that would involve setting up. To do that, I'll tell you what you have to do. I haven't done it, but you need to set up your build.xml Ant configuration file. The exposure has been a nightmare in this video. I'm really sorry about that. But you have to set up your Ant build.xml file to have a JUnit checking step. So it needs to build, and then you need to do your unit test with JUnit, and then you also need to include the JUnit package. I haven't worked out how to do that with Ant. It's very easy, apparently. I haven't tried it, to do it with Gradle and Maven. I haven't tried that though, because we're only using Ant. If I work out how to do it, I'll let you know. But I haven't tried it myself. But I will probably try that and use that in CSCM 94. I'm going to leave this repository here. I'm going to leave it broken because I'm just going to get rid of it. I would go back and reconfigure it to be not broken, but that's very trivial. But that basically is the end of the of this workshop. I'm going to check now. If I have any questions. Anyone has any questions at all? I will go through and answer any questions anyone has. All 2 viewers I currently have. So this is the thing, I don't know what the latency is with Twitch, so I can't tell at a glance. Sort of. So yeah, Banana EMP says can't think of a question now, but I know I will later. I know that feeling too. If you want to ask any questions later, please feel free to ask them in the Discord. If you have it. If not, if you don't have Discord, please feel free to email me. My student ID is 2004599. So just append that to @swansea.ac.uk. So that's 2004599 if you have any questions about this. And that's it. That's everything. I was going to do a kind of interactive voice chat thing at the end, but I haven't tested that, and I know it probably wouldn't end very well. So I think I will just end the stream there. I hope you've had a enjoyable... How long are we going? Almost an hour and a half. We've been doing this. So yeah, I hope you've enjoyed that. I hope that's been useful. I'm going to sign off now. I'm going to have some lunch. I hope you all do the same. So, bye now.